You're probably aware that numbers are used for identification. For example, a computer can be identified by its IP address or a cell phone by its phone number. Similarly, elements are identified by a number, the number of protons in the nucleus. Hi, and welcome back. The topic for today's science episode is masses of atoms.
Masses of atoms. Lesson objectives. Explore the scientific theory of atoms. Describe the structure of atoms in terms of protons, neutrons, and electrons. Differentiate among these particles in terms of their mass, electrical charges, and locations within. The nucleus, atomic mass. The nucleus contains almost all of the atom's mass because protons and neutrons are far more massive than electrons. The mass of a proton is roughly the same as the neutron. As you can see here in the graph, it's 1.67 times 10 to the negative 24 grams. The mass of each is more than 1,800 times greater than the mass of the electron. The electron's mass is so small that it can be ignored when evaluating the mass of an atom. Let me explain this with an example. If you were asked to estimate the height of the school building, you would probably not give an answer in kilometers. Considering the scale of the building, you would more likely give the height in meters. When thinking about the mass of an atom, scientists discovered that even grams were not small enough to use for measurement. Scientists needed a more manageable unit. The unit of measurement used to quantify an atom's mass is the atomic mass unit, as you can see in the chart. Atomic number. What determines the type of atom? In fact, the number of protons identify the type of atom. I will repeat that because it's an important detail. The number of protons identify the type of atom. For example, as you can see in the picture, every carbon atom has 6 protons. Also, any atom with 6 protons is a carbon atom. Atoms of different elements have different numbers of protons. For example, atoms with 8 protons are oxygen atoms. The number of protons in an atom's nucleus is equal to its atomic number. The atomic number of carbon is 6, and oxygen has an atomic number equal to 8, as you can see on table 4. This is where you have the element, symbol, and the atomic numbers that I have been talking about. Therefore, if you're given any of the following, the name of the element, the number of protons for the element, or the atomic number of the element, you can identify the other two. For example, if your teacher asks you to identify an atom with atomic number 11, there you have 11, you would know that the atom have 11 protons, and therefore you know that the element we're talking about is sodium. Mass number. The mass number of an atom is the sum of the number of protons and the number of neutrons in the nucleus of an atom. For example, you can calculate the mass number of the copper atom listed in table 4. So let's look for copper. We know that it has 29 protons, right? And it has 34 neutrons. So what you just need to do is add these two numbers and you will know that the mass number of copper is 63. Atoms of the same elements that have different numbers of neutrons are called isotopes. To identify isotopes, scientists write the name of the element followed by the element's mass number. Carbon with a mass number of 12 is written as carbon 12. Carbon 12 has 6 protons and 6 neutrons. Carbon 14 has 6 protons and 8 neutrons. Carbon 12 and carbon 14 are isotopes of the element carbon. Some properties of carbon 12 and carbon 14 are unique due to difference in the number of neutrons that each element contains. For example, carbon 14 is radioactive, but carbon 12 is not. Average atomic mass. The average atomic mass of an element is the weighted average mass of all naturally occurring isotopes of an element, measured in atomic mass units according to their natural abundances. So as you can see in figure 7, we have boron, but we have two different types of isotopes, boron 10 and boron 11. Boron 10 and boron 11 are two isotopes of boron. These two isotopes differ by one neutron. That's why one have 10 and the other 11. Like boron, most naturally occurring elements have more than one naturally occurring isotope. Summary. Protons and neutrons make up most of an atom's mass. Each element has a unique number of protons. Atoms of the same element with different numbers of neutrons are called isotopes. The average atomic mass of an element is the weighted average mass of all naturally occurring isotopes of that element.
I hope you found this video useful. Thanks for watching, and until the next one, bye!